All right, so we're here with Kent Rockwell, the chairman and CEO of X1 Company in the Kirby Library at Lafayette College. So, Kent, we'd like to talk to you today a little bit about what exactly is additive manufacturing and how you've seen the revolution of this technology.
Additive manufacturing is getting a great deal of exposure in the world today. You're seeing it more and more print across the globe, and there's a lot of discussion about what additive is. And 3D printing, which is, in my mind, a subsection to a certain degree of additive manufacturing. When you think about manufacturing in its total concept of trying to make the perfect product in the lowest cost, shortest period of time, you really have to look at the history of manufacturing, and you think that it's more like a chain where you have a whole series of events that have come along and that have qualitatively improved the manufacturing processes globally. The chain might have started back, 1,000 years ago with the Phoenicians, a couple of thousand, all the way into CNC machines and Six Sigma and some of the different things that have always been adding to the manufacturing processes. In my estimation, additive manufacturing is one more link in that chain. And it's not the end of the chain. It's not the solution, the all-perfect solution. It is certainly a major change, and I believe the real question about whether or not it is an innovative, disruptive technology still has to be answered. Certainly it's growing, but the disruptive nature of that has yet to truly be defined.
And how do you see that going forward in terms of the discussion of whether or not it's destructive in any way?
Well, what is a disruptive technology? Generally, disruptive technologies come when a small player comes with a technology that is capable of game-changing the industry to where the large guys are disrupted out of the process and somebody takes over their position. That's really not happening today. There's a lot of customers that are adopting this, and the early adopters are still evaluating whether or not it will actually, to what extent, I guess you would say, it will actually make a game-changing difference in their industries. There you have to really say, okay, where and who are the innovators? X1's a global company. 30% of our business is in the US, and 70% in Asia and Europe. We see more innovation in foreign countries. Japan, for instance, has to be one of the leaders in innovation because they're so dependent on manufacturing technologies to export to keep their economy alive. And so they're very aggressive about innovation. Some of the European countries are very aggressive. Even Russia more recently has become an innovator in certain regards. The US has been, where it used to be an innovative country, has really lost a lot of innovation, and that's hopefully something that we'll see come back by promoting the additive process within the United States.
Going off of that, when you think about education and facilitating students that have the ability to actually get involved and make those innovative designs that go into additive manufacturing, what role should higher education look to play in the industry? Well,
the educators are where this all has to really kick off. What's happened in this industry is that 3D printing and the technology of printing has been around for quite a long time. It's been around for so long that MIT, where our patents evolved, most of our patents have expired over 17 years because the printing technology was there, but it was only being used for rapid prototyping. And what really drove the change wasn't the change in the printing, it was a change in pre-printing, which happens to be the power of 3D graphics. And as 3D graphics has become more energetic and more adopted by the universities and the other businesses globally, that's really what's driven the additive manufacturing process to start to grow. And I think that that's got to be dependent on the universities. We have right now 22 machines in different universities, with the idea that every year another herd of kids comes out of these schools and learns the value and the power and sees the potential for future, because they are the innovators. They're young enough and free enough to really be able to take this to the next level. And that's why you will see, I believe, an exponentially growing curve for the industrial-based activities that X1 participates in.
Do they vary in any way in terms of what universities you gave or have a certain type of printer versus, say, the printer that's at Lafayette College?
No, they're all pretty much the same one that Lafayette has. There may be a couple of them that have a slightly larger machine. Mm-hmm. In most cases, that's because they bought them. But because they had a school program specific, maybe with some government funding to help develop that interest. But they may be studying, for instance, just the chemical binding processes and what are the materials for binding, or they may be looking at molecular structures. Right now, with the advancement in printheads that we have in our machines, we're looking at the ability to inject nanomaterials through the printhead and be able to create materials lighter and stronger than any materials that have been created before. And so when you get into that kind of technology development, I think it's the youth of the world that finds it most innovative and picks it up and carries it into the companies that want to see that kind of development.
Then going off of that, what are some of the most interesting objects or things you've been able to print and manufacture?
Two aspects of what makes this business so unique is first that you have, with 3D printing and with the power of these new computer graphics, the what they call the freedom of design. And that means is that I had a automotive engineer in Germany come to me, whom we're working with regularly on building automotive engine components. We were sitting talking at a show, and this is 2 years ago in Germany. And he said to me, he said, you know, Kent, the issue that we're dealing with right now is that now that we have the freedom of design available to us, we're no longer constricted in how you make an engine. And it used to be that a cylinder had to be a cylinder because there was no alternative to the functionality of an engine. The cylinder was the only structure that we could create by any subtractive process. But with the availability of 3D and the ability to have that freedom of design, now they can think about, gosh, I can make a cylinder that might be an ovate shaped piece of equipment that turns in some radical new way, that is much, much more efficient and has functionality that heretofore was not available to them. And so they're having to rethink the entire process of how they do design. And that, of course, is something in the automotive world that's several years developing. And we're working with them to see these happen. We've got NDAs with almost every major automotive company in the world and a lot of other large institutions, because each one of them wants to sort of keep secret what they're doing. But it is fascinating to see the amount of momentum that is growing for design change. And as the design change comes, this will drive more and more the necessity to have 3D printing as the only viable alternative to achieving your final product development.
So essentially you're saying that if people do not get on board with this technology, ultimately they will be left behind because it's developing so rapidly? That
is the nature of disruptive innovation, is that you have the early adopters, the risk takers. Some of them will fail because it didn't work for them. But for those that figure it out and get it working right, they will end up usurping the market position of the staid and older companies that refuse to adapt to these new processes. They don't invest the company. And the money and the futures. And so developing an innovative process for thinking at the senior corporate level is something that's very essential to succeeding with the whole 3D printing additive manufacturing world.
So as the chairman and CEO of X1, what steps have you taken to facilitate that growth in your company?
Well, we're a young company. I am, first of all, I'm not an engineer, but I've spent my life in engineering technologies. And it's fun because it's so creative. And to be able to take engineers and an engineering technology that is lacking capital and maybe management direction or strategic direction, and help nurture that and develop that is for me a very rewarding experience, and that's what I do. In the particular case of X1, a friend of mine owned this company, and he died, unfortunately, precipitously in 2007, and his company was still losing a great deal of money because it was a development company, and he knew what he was doing, but he's not with us anymore. And I bought the company from his estate and looked at the technologies he was in. He's in 26 of them. I reduced it to 6, and 2 years later reduced it to 4. But 3D printing was the most prominent one of them. Actually, one of the earliest pieces that we thought would be successful, we were printing gold and silver dental copings, and that was our biggest hope at the time for the business to grow. And then when 2008 came along, right after I bought it, gold went through the roof, and people's desire to put it in their mouth went out of the roof. And I ended up saying, hey, you know, we're gonna try a different approach here. What we did was take the machines that we were using, which were rapid prototyping machines, and a customer bought it because they wanted to expedite development processes and do one-on-one pieces for production design. And so they didn't have to necessarily look at an economic return. They put it in their laboratory, and they said, okay, this thing's going to get this thing for us in 6 weeks instead of 6 or 8 months, and so this is great. We took those machines and we enlarged the job box for the materials that we were printing in. We expanded the amount of materials that we could print, and then we improved the speed efficiencies of these machines about 10.5 times. And by doing that, we were driving the economic return of that machine to where it could earn an ROI for the customer. And then they started thinking, geez, now I can make low batch production units in this, and I can get a return. And when enough people see the design efficiencies that can come from this process, let alone the nature of JIT, the just-in-time delivery. I mean, on our sand machines, a customer getting a pattern out of a normal shop weighs about 18 weeks, and our average delivery time is 6 days for that same product. And in the industry, they're more willing to pay for delivery than they're worried about price. So that's a benefit to us at this point in time. But just to conclude your point, we now have machines that have the economic viability to earn a return. And that's where this disruptive nature will start to be really measured. Because now the customers are going to have to say, can I afford not to have this if my competitors do? Because I might, if I don't have it and invest in it, I might lose my position. And that's where we're just starting to come up that power curve.
So this is kind of a two-sided question, are you limited at all in the scope of the materials that you can produce and the metals? And where have you seen the largest interest from industries that are looking to purchase, your customers?
When I first got into this business, I thought it was all about the machines. And I thought it was all about the better I can make the machines, the better the opportunity will be for X1. I've since learned that it's not just about the machines. While we always want to have the most efficient and continue to improve the productivity, it's really about the materials. and how many material sets can you run across the printer. Every printer we have is a different size, but all printers that we have the ability to print multiple particulates. And the predominant particulate that we have to be printing right now is sand, because the foundry industry and the mold makers found this is absolutely a quick return for us, particularly because of, again, the JIT nature, which is so important to them. But materials is really where it's all about. And so when I created X1, I created two entities with it. One is XMAL, which is our X1 Materials Applications Laboratory, because the development of the industry is to take each customer with a collaboration. It's 6 to 18 months to get a customer to understand the process, invest the process, buy parts from us, and then finally say, either I want to buy these parts for you, through one of your service centers, or I'd like to own the machines and be able to run them. So the materials applications is very, very specific, and we are now moving through a broad spectrum of new materials. We put together a very large laboratory. Fine young lady from Lafayette is in our chemistry laboratory, just came in and is working for us, and we're proud to have her. And we have a machine here at Lafayette that Dr. Ferry has been very helpful with. So getting more materials. What are the materials that are most interesting? Titanium, aluminum, tungsten carbide, and then there's a whole bunch of little offshoot materials that I frankly think are perhaps even more interesting in a final business strategy in the carbon material section. And we, as opposed to the other people that are dominant in the printing industry, do not do polymers. The MIT patents gave the exclusivity in polymers to another company and gave us exclusivity in metals. And so we spend all our time in the metal sector. The guys that are our peers in plastics are wonderful, and they're doing wonderful things, but their business model is much different from ours. Their customers are much different than ours, and they've been highly successful. X1 is, I think, being very successful in what we're doing, but we're a smaller player coming from where they've been at the market for 5 years, and we're just really moving into it in a big way now.
Where exactly do you see X1 ending up, and the future of the company in terms of what your capabilities will be as they develop and how you're going to utilize that?
As an entrepreneur, and this is my 4th time running a public company, which I swore I'd never do again, but sometimes necessity is the mother of invention, and it's worked out well in this case. When you're this small in a highly incubative and innovative space, you have to be strategically very, very fluid. And you've got to look at your strategies every 6 months and say, hey, is this the right road, or is there a new road opening up over here that we should be going down? And then you've got to have enough wisdom to know, can I match my capital availability with these opportunities? Because we see so many opportunities that very, very easy to get diverted, and then you get diluted and never deliver customer satisfaction. As opposed to the prosumer market guys that are out there in the polymer world, we're in the industrial sector. I would rather have 150 to 200 high-quality industrial customers than the thousands of customers that you're looking at when you're in the consumer market. The polymer guys are using an HP strategy, which is basically sell the ink, and they get very, very high margins on their ink. We have industrial customers that have very sophisticated buying organizations, and you could not get 70 and 80% margins selling ink, or in this case, the metal powders and the other things that go. It's just not a rational approach to a good collaborative relationship with a customer for long term. They'll be willing to let you have a reasonable margin as long as you service them well. And so you have to develop that collaborative mentality and maintain it. And so it's a bit of a different market experience for us than what it is for the others. But I can say that right now that we've got more customers knocking at the door than I have people to answer it. And so we're having to be strategically selective in how we develop the various opportunities we're looking at.